Hi everyone, welcome back. If you'd like to press like for me before you forget, that'd be really helpful. I find I often forget to press like on other people's videos, so I've been going through and having fun pressing like on people's videos. So let's have a look at this. How do you get a cubic when you've been given a graph? This was in the exam that I gave to my Year 11 students just a couple of weeks ago. Now, they were given the graph, it had different numbers, different intersections, but this is one I made up, which is using three x-intercepts of -2, 2 and 6. Three x-intercepts, or we used to call them roots, of -2, 2 and 6. So most students, like every student in my class, had no problems with saying the opposite of -2 is +2 and putting in the bracket with an x. The opposite of 2 is -2, putting in the bracket with the x. And the opposite of 6 is -6, putting in the bracket with an x. But what has everyone forgotten? There can be another number here. Where does that number come from? I could take that graph and I could multiply it by 2 or 3 or 4, or divide it by 5 or times it by 3/4 or times it by 2/3. Any number can go in there, which is its dilation factor vertically. So all it means is I could get this graph, I could get the max and the min, and I could just pull them out, or I can push them back in. So you can't tell how far it's been pushed up, or it's been pulled up, or it's been pulled down. And the only way you can tell that is by using a point on the graph other than the -2, the 2 and the 6. So if I look through my graph, none of those numbers, that just misses, none of these are particularly nice. I could estimate, oh, that one there looks like it's nice, and exactly this one I could use, but I couldn't use that one. It might be too small to see it on the video. Hopefully you can see it. But this one is really obviously meant to be 0, 4. So now I go back to substitution, and I'm going to write the old school 0 and 4. And that 0 and 4 will give me the A value, which gives me the full marks for the question. So let's have a look what it is. I still have students who need to write X and Y. Not many do it, but I see the mistakes that people make. So the 4 goes where the Y is, and we've got the A times by, and now I'm going to write it all in. That's a 0 plus a 2 times by a 0 minus a 2 times by multiplied by a 0 minus a 6. So what do we end up with for our equation? You could really shortcut that. That's a times by 2 times by -2 times by -6. You could look at a shortcut if you wanted to and just go home and multiply those three numbers there. That's the same as multiplying those three there. Two negatives become a positive, so I've got 4 6s are 24. So I've got 24a equals 4. Now, I still do have students, like I've said in the parabola video I've just made, that people will go 4 into 24 goes 6. It's like under exam pressure, assessment pressure, people do silly stuff. Keep on saying if you write that way, it solves the problem of people making silly mistakes. And we're left with a 4 on 24, which is a 6. So let's go back to our equation. Now our equation is now 1/6 of x plus 2, x minus 2, and x minus 6. Now a lot of times in assessments they don't want you to leave it in that form, they want it simplified. In other words, expanded out and written in conventional form, or what we'd refer to as general form. So I'm going to leave that 1/6 there. Hopefully a lot of people are okay that this is called the difference of two squares. So you can go x times x, x times -2, 2 times x, and 2 times -2. Or you can simply write x times x is x squared, because the two middle terms will eliminate each other. And you're left with 2 times -2. Most people should already know that. So then what do we do to expand the next part? Oh, I go some red pen. We're going to go that times that. And what's really going to do? I'm going to ignore the 1 on 6, the 1/6, and I'm going to write x cubed. And I'll go, the next eyebrow would be -6x squared. The next eyebrow will be -4x, and the last eyebrow will be +24. Now, don't forget, I'm always nagging about the B word, brackets. It is a laughing point amongst maths teachers of how many kids don't write brackets in. So student after student will just write an answer like that and write as a 6 to that, and you go, no, the 6 affects everything. So the purpose of brackets is to get people to realise that it affects everything. So what do I do now? I've got a 6th of x cubed, so I'm going to write it over here. I've got a 6th of x cubed. I've got a 6th of -6x squared. Most people are okay, you cancel the 6's. So you're left with a -x squared. I do worry about people with fractions still. This one here, a 6th of -4x. I'm going to write for now, I'm going to write that as multiply the top, so it'll be -4x. and multiply the bottoms. 6, that'd be a 1 on the bottom if you wanted to write a 1 there. Plus or minus 4x on 6. And the last bit is 1/6 of 24, which is nice. I made up the question to be reasonably nice. So a 6 of 24 is 4. And there's your equation. Only thing you probably should tidy up. I imagine a lot of times people wouldn't be worried about if you left that not as 2/3 plus 4. Now you might notice here I've written this as a fraction out the front and I've written that as a fraction in the term. So if I wanted to, I could write that as 6 of x cubed minus x squared minus 2/3 of x plus 4. And there's our proper answer to it. Don't forget that a lot of people write the 3 of these down and maybe even expand it out. They've forgotten about the a. And how do you get the a? Substitution. And just be careful when you're expanding that everything expands out. Oh, I hope that helps. It's been coming for a while. It's something I've seen so many people get wrong. Hopefully you find that helpful, and I'll see you in the future. Bye for now.